So we are going to solve some nonlinear systems of equations today. So some equations like quadratics or circles, so things that aren't just straight lines. We're going to do substitution or elimination. So if you already have a variable that's solved for, like I have y equals negative x, then I would just go ahead and substitute that value into my other equation. So I'm going to replace y with negative x in my first equation, and then do a little bit of simplifying. That gives us a quadratic equation, x squared plus x equals 2, which if we get 0 on one side, we could solve by factoring or quadratic formula. I'm gonna, guess and check factor here because I don't think there's too many options. To get x squared, I'm gonna have to have x and x. To get negative 2, 2 and 1 are the only things that multiply to 2. I just have to make sure that my signs are correct. Nope, that's going to be backwards. So I'm going to have to flip that to x minus 1 and x plus 2. Make sure to check your factoring if you're guessing and checking. Don't want to screw that up. All right, set each factor equal to 0. So x minus 1 equals 0 and x plus 2 equals 0. Is going to give us x equals 1 and x equals negative 2. So remember, you're not done because those are just the x values. So actually there's going to be two solutions here. If you think about graphing this, there will be 2 points where my lines intersect at. So when x is equal to 1, we need to see what y value we get to go along with it, and also when x is equal to negative 2. So let's start with x equals 1. Pick one of your original equations and plug x back in. I'm going to use the second one because it looks easier. So if I plug in 1 for x, I get negative 1 for y. So 1, negative 1 is one ordered pair that's a solution. If I plug negative 2 in, I'll get a y value of positive 2. So negative 2, 2 is another solution. Really, I need to check these in both of my original equations to make sure that they work. I have checked them, they do work. We could check by doing a little solving by graphing. So if you graph these two, it's a parabola and a straight line. And if you look at their points of intersection, you can see the ordered pairs that we got for our solutions. One thing, though, is we will only be able to see our real number solutions from our graph. Any non-real complex ones, we won't be able to get by graphing, which is why we need to be able to use algebraic methods as well as graphing. So if I look at this one, substitution's not going to be a good option. I can't solve for x and get it by itself because I have x squared and x to the first. I could solve one of these for y, but then I'd have to plug it back in and it would turn into quite a mess. So I'm going to do elimination instead. If you look, trying to eliminate x isn't going to work because I'd have to multiply by 2 to eliminate my x squareds. But then I'd have 4x and 6x, which wouldn't eliminate, and I'd still have x's and y's. If you eliminate y's, though, I'm going to be able to make that happen. So let's multiply my first equation by 3 and my second equation by 4. Actually, let's do negative 3 on the first one. And then I'll have a negative 12y and a positive 12y that add up to give me 0y. So if I multiply everything in that first equation by negative 3 to create an equivalent equation, and the second one by positive 4, my new equations are going to look like that. And then if I add those together, I'm going to get negative 10x squared. Oh, my x's eliminate too. That's kind of nice. 0x and 0y equals negative 40. Then I can divide both sides by negative 10, which gives me x squared equals positive 4. Take the square root of both sides, and you get x equals, don't forget, plus or minus 2. So I have x values of positive 2 and negative 2, and I need to plug them both back into one of my original equations to get y. Okay, this is going to get a little bit messy. Doesn't really matter which equation you use to plug it back into. So I'm just going to plug back into my first equation. So if I plug positive 2 back in there, I'm going to end up with 2 squared 4 times 2, 8, plus 8, 16, plus 4y equals 18. Subtract 16 from both sides gives you 2, and then divide by 4 and you get y equals 1/2. So if x is 2, y is 1/2. Oop, that was some thunder. And then if you plug -2 back in, same story, I'm going to use the second equation. You're going to get, let's see, -2 squared is 4, times 2 is 8, plus -8 is 0, so just 4y equals 18. And then you can divide both sides by 4, end up with 18 over 4, and those are still both divisible by 2, so y equals 9 over 2. So you have -2 9/2. And again, check them. I know you don't want to, they work. And I'm fine if you check by graphing, just realize if you have complex imaginary ones, they won't work to check by graphing. All right, let's look at this one. So elimination is not really an option because if I try to eliminate, my first equation has x squared and y squared. My second equation has x to the first and y to the first. So if I add those up right now, like even though y squared and y, one's +1, one's -1, they aren't like terms, so they don't add up and get you 0 y's. Substitution is going to have to be our approach. I'm solving the second equation for y. You could solve it for x. I'm going to take what I got for y and plug it into my first equation. So I have x squared, and then make sure you put the -x plus 5 in parentheses when you plug it in, equals 5. When I square that, I am going to have to multiply it out times itself, so I'm going to write it out twice and then multiply it together, which, distributive property, it's a good idea to go ahead and make sure that you keep the result that you get in parentheses because we'll have to subtract all of it. So we'll have x squared minus 5x minus another 5x plus 25 equals 5. If I distribute my negative and change all my signs there, I'm going to have that be -10x, which will make it a +10, and then minus 25. Ooh, kind of nice on this one, our x squared subtract to 0. So we just get a linear equation that we can get x by itself by adding 25 and then dividing by 10. So, oh, just one x value. So x equals 3. I'm going to take my second equation, because that looks way easier to plug it back into, to get my y value. End up with y equals 2. So 2, oops, don't mix up your x and y and get them backwards. That's something that's easy to do and screw up. One more where we are just writing a system of equations that could be used to find two numbers that have a sum of 17 and a product of 42. So I'm just going to let x and y be my first number and my second number. I don't really know anything about them. The two numbers have a sum of 17, which means they should add up to 17, and a product of 42, which means they multiply to 42. And that's it.